Hey everyone, how's it going? Welcome to the stream. So tonight I thought I'd switch directions from developing more stuff in the debugger and actually start focusing on writing some unit tests. This is something I haven't done yet. I don't really have any unit tests so far for any part of Vectrex. To be honest, I'm not really someone who has a lot of experience with it. I do come from the games industry where we typically don't have a strong culture of writing unit tests, but the last over a year or so I have been at Google where it's quite the opposite. Testing is everywhere and I've come to really enjoy the benefits of it, and I'm definitely feeling it now. The more I add stuff to the debugger, the more I feel like I'm potentially breaking things. Plus, especially when I do refactoring of code, I'm always worried that I'm messing things up, and I just can't, I can't keep manually testing for things. I'm going to run into corner cases and all that. So, and the other thing I thought was that eventually, unlike the, how can I say this? So like the emulator itself, it's what it can do is pretty closed. It's pretty simple, It has to play Vectrex games, and that's pretty easy for me to test. And let's say that the input space is relatively small. There are only a certain number of Vectrex games that exist out there. I actually test them all. If they seem to be working, I'm pretty confident that the emulator works. Sure, there are some new homebrew games that get developed, and some of them might not work, and then if that happens, then I can fix it. But let's just say that the input space is relatively small for the emulator itself. On the other hand, it's not really the same story for the debugger. The debugger, the input space is pretty much any C++ program, C or C++ program that might be written, and it's very difficult for me to cover everything. I try to think up examples, but I'm going to miss some, right? So it would be nice that as I develop it, if there are, corner cases reported by users or cases I haven't thought of, that I'll be able to write a unit test to reproduce whatever bug they have, fix it, and then that unit test will live on. So to make sure that doesn't happen again, right? I don't regress. So that's it. So I've convinced myself that I think it's worth it. So you'll watch me stumble through this a little bit. I'm not a pro. I don't have a lot of experience with it, but of course, how better to get good at something than to actually do it. So far, what I've done is using VC package here. I went ahead and installed gtest. So that basically makes gtest available for me now to start consuming from Cmake. Apparently, actually, Cmake has even support for running the tests at the Cmake level. That's what this enable testing is about, and add test. I might use that. I haven't decided yet. Because Cmake has this whole test system there. Sounds pretty good, but for now I'm more interested in just having a program that's a test and that I can run that makes use of gtest. So more likely this is what I'm looking at here. So let's start off by, let me just make sure I have nothing here that's important. Yeah, I just fixed that. This was a test from last week. All right. Okay, so let's start by going and figuring out where I'm going to put that. So I'm going to make a root folder here. I'm going to call it tests. And I guess I'll give it a name. So I think what we're going to do is, this is for the debugger. So I was thinking just debugger tests. How about that? And we're going to create a Cmake list. I think we're going to do I think I have one here. No. Let's see here. Libs, I don't have one right at the root, but in each one I have one. Okay, so we'll do the same thing. So we'll create a Cmake lists file right here. We'll also create a main CPP. Okay. Yeah, let's start with this one actually. All right. Did I use underscores? I don't remember. I did. Okay. So debugger tests. Let me open this here. Maybe I should call it Vectrex debugger tests. I don't know. I guess it's all right. Okay, that looks all right to me. Don't know if I need a source directory like I was doing for the other ones. Should I do that? Maybe I should. Yeah, let's do that. So this will create an executable. And in this case, I guess we'll need core, not emulator, none of engine. I think we just, actually, is that true? I might, in order to use debugger has its own dependencies. So I'm not sure. Let's start with this. Let's see what happens. So this should be enough at least to get it building, and then we'll add the dependency. So let's see how this goes. So I'm doing the Cmake generation from within Visual Studio. So that should actually generate correctly. And actually, no, it's not going to do anything because I did not add this to my root Cmake list. So I'll do that now. Okay, this looks all right. All right, so let's go to this is the root one. I'll just put build tests. All right. Now, if we said build tests, I can do that a little bit lower here. And we'll do add subdirectory tests. Debugger tests. So this should actually bring in the Cmake list that I just added, and it should actually add something in here. There we go, tests. This is, well, actually, this is not my targets view. So let's go to targets view. Debugger tests. There it is. Now let's see if this actually builds. Not that there's much to build in there. Did I like do a build all? It looks like I did. Huh. Right, missing a main. Just curious why it seemed to have built so much. Probably because Debugger brings in its own dependencies. That's what I think, which I guess makes sense. I suppose I was being very explicit about bringing these other dependencies when it was not really necessary. Okay, so let's go into the main. Should be that one. Okay, here we go. Why does it keep building everything? Probably because I touched a Cmake list, so considers things dirty. That's my guess here. All right, build succeeded, so that's good. So ideally here, I should be able to introduce dependencies from the debugger. Let's just see if that works. So I should be able to say include RST, so it's actually debugger, RST parser. Let's just see if that works. Okay, good. Okay, so next, I go back to the Cmake lists here, and we're going to try to find, actually that's something I'm not sure if I should be doing it here or if I should be doing it in the root. I think I should be doing this in the root for at least the find package portion. So let's go here. So basically if we're building tests, we want to find gtest, it's required. I guess I didn't do that for other things. Okay, so find package is actually not working. Just check something. Right, so I did wait till I was deeper into the find packages. Anyhow, so let's see here. Target link libraries just become module name. In fact, I already have one down there, so let's do this. Technically speaking, I don't really need the mocking libraries, at least not to start with. Let me just remove those for now. Again, this won't work because it's not finding gtest, and I think this is because there isn't a find gtest that comes with Cmake. Let's find out some more about this. So apparently there's a built-in find gtest. So why is it not working? Let's see. Maybe my Cmake is too old? No, 3.17 is definitely not old. So just find gtest. So it should be in there. Maybe it's because of the config. So here's find gtest.cmake. Find it. Locate the Google C++ testing framework. Do I need to write enable testing? Maybe I do. But here it doesn't put the config. And I don't think I generally do put config because I'm not looking for the config version. So let me try with oh no, I do normally put config actually. So then why isn't this working? Let's try that. If I recall, config is like the newer way of doing packages. So maybe the find gtest that comes with Cmake is like the old module format. Okay, so this is a bit different now. So now it's saying Cmake error. Yeah, this is not. I think this is actually worse. Could not find gtest, missing gtest library, gtest include directory. Strange. Oh, wait a minute. It installed it for x86 and probably because I need it for x64. That's probably what's going on here. That sucks. Okay, all right. At least we have a path here. Let me check something. I don't remember if I had to specify. Not that. Ah, there it is. Okay, I do need to specify the triplet. Okay, well this is gonna be a bit boring because we're gonna have to like let VZ package do this install. It's gtest, right? Hopefully it won't take too long. I did this off stream so that we wouldn't have to wait for this portion, because it basically has to download the source and compile it for like 4 different configs. And I think Google Test is pretty big. Although I think here it actually tells us how long it took, right? 42.83 seconds, really? Or is that 42 minutes? I hope not. No, I guess not. This looks pretty fast, actually. 1.54 minutes. Okay, so this shouldn't be too bad then. Oh, there you go. That was pretty fast. So let's try this now. Okay, so it found it, so that's great. Oh yeah, and that's a mistake. Move that. Excellent. Okay, so now that we have that, what's the next step? I think there's like some kind of bootstrap thing for Google Test. Let's see here. Let's go follow the primer. Okay, writing the main function. So here's some boilerplate. You can start from this boilerplate. There it is. Okay. So we'll include gtest that way. It's mildly annoying that building the debugger has to build all this stuff. So part of the problem is that my debugger is meant to be able to run the emulator. So it sort of has a dependency on core, CPP DAP, and emulator here. And an emulator has a dependency on pretty much everything. So this is why this is happening. What I should probably do is split out the parts of the debugger that have nothing to do with depending on the emulator. But it's all right. Doesn't matter. Like in this case, all the stuff about parsing RST files, like listing files, which I really should rename to stabs parsing. So parsing like the stabs information from those listing text files, that should be its own library. Like I could have like a stabs parser or a stabs library, and then I could just depend on that and test only that. So that would definitely simplify this dependency here. Oh, I have a macro called fail. Yeah, that's not as fun, is it? This might be a problem, but we'll see. I think it's okay. I think what it means is that from this point below, fail will be the one that's used by gtest. Okay, there we go. So this is using test fixtures, which I probably will want because I have some things that I'll do for many, many tests. But before I do a fixture, let me just go for the simpler non-fixture case. Do they have that here? Just a regular test. Test suite name, test. Something like that. So let's say we're going to do, the suite will be stabs parser tests. Yeah, I'll just call it stabs parser. Basic types. Okay, so now comes the more interesting bit. What am I going to do? So this is what I have to think through. Ideally, what we want to do is write some C++ code, compile it using this compiler that requires Docker, which is what we're doing, to produce the listing file. And then from there, we want to take that listing file and parse it. So the RST file, and actually parse it. So this is quite a few steps. So let's start with writing our C++ program. So it'll be something like how do we do this again? I always get confused about how to write raw strings in C++ because I write them in Python, I write them in different languages, and I always forget. Oh, actually, I have some in my, where is it? RST matchers. Oh, that's right. It's true that I did not solve the problem yet of having a simple CPP file. I still have this requirement that I include some dummy file because otherwise I don't correctly parse the name of this file. So that's a bit of a problem I'm going to run into right off the bat. So let's say we'll, okay, well, I'll deal with that later. Int main. Yeah, I think all I need to do, we'll just start with something like this. How about that? So that's the source file. What we're going to need to do is have a way to output source to a file, or like write source to a file, invoke like make, I suppose. So something like this: write source to a file, invoke make, make sure RST files exist, parse the RST files with the RST parser, and then test that the values in debug symbols are correct. So that's all. These last two parts go together. This is like the easy part. The hard part is above. Writing source to a file is easy, but I need some kind of structure now for these files that I'm going to write. Plus, I'm going to need a way to spawn processes and get their output, get the result to make sure that they did what they're supposed to do. So quite a bit of stuff to do here. I'll take it one step at a time. Let me get back here. So I need this. I need some source. Don't really need these things, I think. No, don't need those. Don't need that. Don't need that. In fact, I don't need anything from here. What is it again? It's tasks. That's what I wanted to see. Oh, here. Hey, thanks for the follow. Mario Caesar XYZ. My volume was so loud, it kind of freaked me out of there. I didn't realize. Okay, so let's see here. So yeah, make file is what I need. And I'm gonna have basically like a build template. My idea here is that I probably want to copy this to a temp folder and then copy my main file into its source. That's what I'm thinking. Or maybe not into a temp folder, but like into the output bin, the binary output directory. Something like that. I'll come up with something. And then yeah, and then I need to basically get rid of this stuff here. What's foo here? Get rid of that. Get rid of this. I'll leave dummy just for now because I'm gonna need it. Like I said, I know my parser is gonna fail if I don't have at least another file to include. And then we'll get rid of it when we can. The make file also is going to need a little bit of work in here. I'm just going to put nothing. I'll just write unit tests, unit test. But to be honest, we won't even get to this point. I'm probably going to end up simplifying this because we don't need to actually build the bin file. We just need to generate the listing. So let me see here. I'll probably stop before the bin and just look for the S19. Yeah. Okay, I'm going to leave this alone. We'll see how this goes. So say I've got this build template. Okay, so write source to file should be easy, but before that, what we're going to need is okay, copy build template to a temp location. So let's start with that. I'm wondering if I should always generate a unique temp location or if I want to just reuse the same one. Probably reusing is not great, but then again, I want to make sure I blast them. Yeah, let's just start with simple because I don't even have like a nice utility in C++ to generate like a unique location or a unique path. So we'll yeah. Ideally, I will actually resolve this. Oh, there's actually a get temp path. Maybe I could use that. This will do it for me. Get temp path. There you go. Oh, look at this. We could use file system. Sweet. Perfect. That's exactly what I need. Okay, so that returns a temp path, and then we'll put it into okay. Now we need to do the copy. So does copy do like, I don't know, we'll find out. I don't know if copy will actually do the recursive copy. I see there are copy options, so probably there's something in there that we can use. Yeah, I think that makes sense. And where do we want to copy from? So maybe I can assume we're running debugger tests from somewhere. Don't really have the info here. I need access to this build template folder. Normally we'll be running out of some output folder, so it's not clear. All right, for now I'm going to assume we're going to be in some kind of build folder like we typically are. Either in here, although this here would not actually work. There's no actually easy way for me to get this, is there? Let's see what this does. Copies the file or directory from file to file or directory to, comma, using the copy options indicated by options. The behavior is undefined if there is more than one option in any of the copy options. Option group present in the options. Present in options. At most, one copy option in each of the following option groups may be present. Sure. Okay, so let's just see how this goes. One thing though is I'm assuming that this is going to be in the wrong folder here. Let me see. Failed. Source, local variable not used. That is true. Okay, what I'm going to do for now is I'm going to, I'm going to go like this, and we will make sure to run it out of the root directory. Why isn't it like this? Specifies the full build path to the build target. That's not what I want. So where's the working directory? And why are these, if provided, I thought it would be this, but it looks like it's got a warning symbol on it. Alright, let's just try this. Alright, so let's look at our temp directory. This looks like a valid path, which is great. Let's actually cd into it. Oh, of course, we probably need to make this next one. I just thought about that. This actually probably won't work because this directory doesn't exist. But let's just see it fail. And there we go, it failed. Exception thrown. Do we actually get any information about this? The system cannot find the file specified. So fs make create directories temper Okay, so now we have Vectrex unit tests. Okay, so copy still failed. All right, it's saying the system cannot find the file specified. Tests, debugger test, build templates. I'm guessing it's this, probably the current working directory thing that I set is not working right now. That's my guess. Make sure there's no typo. That should be build template. No, that's fine. Let's find out what our current working directory actually is. Yeah, that's what I thought. So we're in out build x64 debug. So then this thing that I'm doing in the launch is not actually working. Maybe current directory is what we have to set here. Let's find out. Oh, okay, that worked. So current dir it is. So this now should work, and there we go. So it copied everything into Vectrex unit tests. But it copied the inside of build template rather than the folder build template. I guess this works a lot like Unix does. I thought it would copy it to this location as that folder name, but that makes, I guess it doesn't, so that's all right. Try that again. Perfect. Okay, so we now have what we need. So now what we need to do is take our source file here and write it out into a file called main.cpp, or whatever we really want. It doesn't really matter. So we just need a little function to do that. Is there already a function to do this? That would be interesting. I guess not, eh? Anyways, so basically, we could use, I guess, f streams for this. So what we want to do is create an f stream, and basically, I think this creates it already in text form, and then just output the string, really. That's it. Pretty easy. I guess we can just do this. It's not OFstream, it's fstream for the include file anyway. So now the source file should be written out here, and there's our main file, including some extra lines at the top, probably because we have some extra lines, which is fine. Okay, great. So next is all right, so this is going to be a bit more tricky. Invoking a process, a little bit more annoying, and it's also platform specific. So I did a quick search earlier thinking about this, and I was looking to see if there was like a simple library that I could use to help me, because also I wanted it to be cross-platform. And I found this one here, and what I like about this is its single header. It's called subprocess.h. A simple one-header solution to launching processes and interacting with them for C++. It says GCC, Clang, and MSVC, so Linux, Mac OS, and Windows, which is pretty much what I want to support. And it looks really easy to use, which I like very much. So you can give it a command line that's made up of multiple parts. So this is a lot like in Python. You specify an array of string for the command line, terminating the array with a null. And you can even get to write to the standard input of a child process. You call subprocess.in to get the file handle to write with. That's pretty nice. You even get reading from the standard output of the process, which is pretty sweet. Care must be taken to not read from the stood out after any call to subprocess destroy. Sure. Reading from the standard error of a process. You can wait on a process with join. That's pretty nice. And destroying a process you created. Really similar to Python. Who copied who? Pretty sure this was copied from Python. Python's so old. And this looks like it's relatively recently, like there's updates to it, like 13 days ago. That's pretty nice. There's even asynchronous reads. If you want to be able to read from a process before calling join on it, you cannot use stood out or stood error because the various operating systems that this library supports do not allow for this. Instead, you first have to call create and specify the option enable async, which enables asynchronous reading. Then you must use the subprocess read stood out and subprocess read stood error helper functions to do any reading from either pipe. Note that these calls may block if there isn't any data ready to be read. Unlicense. Unlicensed. I think I can use this. Mine's MIT licensed. Seems pretty free to me. So yeah, I say we give this a whirl. So the way I'm going to do this is add it as a submodule in this case. And it's small enough that I think I might end up using it anyway, so not just for tests. But for now, it would be for tests. So let's go see about adding this as a submodule. Sorry, it's not in here. It's actually in Git. So we'll git add submodule. Let's get the path. And I think we need to do first where we want it to go. So I have an external, and this is going to be subprocess, like this. Did I see that right? The actual thing is called, whoops. Also, the project itself is actually called subprocess.h. That's weird. Because I was like noticing the .h.git. All right. Oops, I always do this wrong. It's git submodule add. I think I got it the wrong way. It's the other way around. Do this once in a blue moon. There we go. So there it is. Actually, you know what? Let me redo that, because so I see that it doesn't have any Git file, Cmake file, and I like to add a little Cmake file so that I can just do an app subdirectory, and this way, I can inherit the environment and all that. So now this can be a bit tricky. One thing about Git is it doesn't like when you have like even if you dinit, it still remembers the module that you added. It's like it's going to be in here somewhere. See, subprocess is still there. This here is going to end up screwing me over unless I actually delete this. Oh, hey, how's it going, Bama? Or Brahim? Long time no see. Okay, I'm just going to delete this. I've had this issue before, so. Okay. So what I'm going to do, learning from your video, you mean like my previous ones? Oh, that's cool. Do you mind me asking what you're actually learning? I always wonder what people pick up from my videos, if anything. Especially when I'm like stumbling through it. Why would this be ignored? That's a strange thing. external subprocess. How could that be? Mostly your process of solving things, methodology, plus tools. I am old school. Oh, cool. Well, I'm glad you're picking up some stuff. I gotta check out what's going on in my git ignore here. This makes no sense. Git submodule add path to the git folder into external subprocess. I just added it before to subprocess. See, this has no, because it doesn't like that I repeat subprocess twice. What does that have to do with my ignore folder, my .git ignore, I wonder? Okay, hold on. Let me check something. Oh, maybe this is why. Okay, let me reset that. Okay, there we go. It was a strange thing to say that it was a problem in git ignore though. Anyway, so there it is. So what we're going to do is, just like I have here for the knock library, I'm going to copy that into the root here. And I have no idea if this is even going to work, but it should. It's an interface library. Huh, I don't even really need to put all this. Okay. Okay, so if I did this right, by adding the subdirectory to external subprocess here, we should now Sorry, it's too many windows. Where'd it go? We have an include directory for subprocess. In fact, I should probably include my current directory and then just do include subprocess / subprocess.h. That probably would make more sense. Let's try that. Okay. So we come back to here, and I should be able to include subprocess.h. So let's see if that works. It's not looking good. I don't know if I can trust this error squiggly just yet. Oh, maybe I can. Cannot open include file, no such file or directory. Ah, yes, I know why. We haven't actually, so we've done an add subdirectory, but we need to say that we depend on this library in our debugger tests. So let's go take care of that. Yeah, in fact, I think I'm gonna go ahead and put this in the actual test Cmake lists. Where is it? So what I've done is in the Cmake list for the debugger tests, I've done an add subdirectory starting from the source directory up into external subprocess. That will bring in the target and define it. And then here I'm saying I depend on that target, which since it's an interface target, it's really just a header interface target. But this should allow me now to do this include correctly if I did it right. Okay, wait, there's actually a Cmake error here. Add subdirectory not given a binary directory, but given the source directory is not a subdirectory of debugger tests. When specifying an out of source, oh yeah. Yeah, okay, so maybe I won't do it here. I'll bring it back. This is always the problem with add subdirectory, is that it doesn't like when you give it so the name is subdirectory, right? So if you don't give it an actual subdirectory of your Cmake list, it complains about it. Now there is a way to solve it. You can put a space and put another path for the binary directory, and that's fine, but it's like less idiomatic Cmake, I suppose. That's why actually I have all my add subdirectories here in the root. So then this adds the target, and then I consume the target from within here. I should stop changing Cmake lists from here. Let me close this. Because when I do that, Visual Studio doesn't always see it. See? So let's take this off. Let's go in here, and it's already there. Okay. Okay, generation finished. So now you see there's no more squiggly here. So this means that this actually should compile. That would be great. So then after that, we can start start building, invoking the make command. Now in this case, it actually means invoking a Docker make. There we go. So build succeeded. So let's see how subprocess works for us. So first, what is the command we want to execute? To know what that is, I'm going to actually refer to how I build here in VS Code. As it happens, I have all of this stuff in my tasks. We basically want to do the make debug docker command here. So it looks like this. I'm going to just copy this in here. So docker run, I got to give it a folder. Then that maps to, in the Docker image, some folder here. This is the name of my, so this is the Docker image of the fork of GCC. Now I did not create this, I did create the Docker image, but this is the fork of GCC that can compile for the 6809, which is the processor for the Vectrex. I made this Docker image so that it's easy to do this from anywhere. Previously, you'd have to find a way to build it yourself. Very painful process. I went through it and I don't want to go through it again. So now I maintain this Docker image for anyone who wants to compile for the Vectrex. It'll compile C and C++, which is nice. The only downside is that it is an old fork. So I think it's like GCC 4.3. So it only supports C++ like 03, 9803 and not 11 and up. So it is what it is. All right, so let's see here. I guess the subprocess thing really does need an array of things. And I guess I know why it does this. It's so that you can put spaces, which is okay, I guess. I mean, it would have been nice if there was a way to like yeah. I guess I could do my own splitting and all that, but probably not worth it. So this would be normally a path to the workspace folder. So in my case, we're talking about the build directory here. And in fact, what I need to do this doesn't really matter. -t -i I mean, I wonder, can't I? No, never mind. So many arguments. Debug equals 1, followed by -c. What's the -C again? I don't even remember what this is for. Oh, right. This is to tell it which folder to make. This is an argument to make. Let's do that. It's just so that I can see the relationship here. So we're mapping all the way up until build template to root build template, and then telling it to make within that folder. Okay, so that's the command line. So let's say command. So subprocess create command. Okay, so let's go look. Oh, and I need a null element. I suppose I could put this or 0. Okay, so let's start with 0 as an option, like in their example, and let's just see how, like, where this takes us. Like this. And then after that, I guess we want to wait on it. Oh yeah, and we probably want to check that this returned the valid value, right? Yeah. I'm trying to figure out which assert I want to use. I feel like I can expect 0. Expect. Anyways. Okay, and I also expect the process return value to be 0. So shall we see what happens? I mean, ideally I would also want to see in the stood out the actual result. But let's just start with this, and we should be able to at least see in the output directory if this actually works. See here in this folder here, right in the temp folder here, we should see a bunch of files get created if this actually works. So let's go for it. So let's see, we have a nice big command here full of arguments. So let me just make sure this looks right. This argument is the path to build template colon and then mapped to root build template. That looks right. So this looks okay. So let's go. Result is 0. Nice. Join. Process return is 1. So don't see anything here. So that failed. So let's see what is happening, what stood out and stood error, I suppose. I guess I'll read it in chunks or something. I think fgets returns how many bytes it actually read. Why is it saying char star? Oh, it returns a char star. Okay. I'm not sure what's the right way to iterate over the stream and get everything. Reads characters from stream and stores them as a C string into string until num-1 characters have been read. Oh, so I don't need to do the extra 1. Or either a new line or end the file is reached, whichever happens first. A new line character makes fget stop reading, but it is considered a valid character by the function and included in the string copied. A terminating null character is automatically appended after the character is copied to string. Notice that fgets is quite different from gets. Not only fgets accepts a stream argument, but also allows to specify the maximum size of string and includes in the string any ending new line character. On success, the function returns string. If the end of file is encountered while attempting to read a character, the end of file indicator is set. If this happens before any characters could be read, the pointer returned is a null pointer, and the content of string remains unchanged. Oh, okay. So then actually, what I had before was probably fine, because we have a null pointer in the output. So I can go back to 1024, pass it the actual size in bytes, and print it, I suppose. Let's see if we get anything from this. So this is the output, by the way. So we'll be paying attention to that. Okay. So this actually did not do anything. All right, Mario Caesar, thanks for hanging out. You have a good night as well. Hey, thanks, man. Thanks for the bits. Yeah, not sure what's going on here. And it looks like even the join should have returned a non-zero, but it's returning a 1. So that means something went wrong. But actually it's strange because this returned 0 up here. Oh, now it actually returns 0. Huh. Okay, so the join returned 0, but the process returned 1. Which, may be valid. I haven't actually looked at what Docker returns. But the thing is, if this were running correctly, we would have ended up with something in here. So let's do this. Let's actually take this command, right? And let's run it ourselves. Just make sure that it is doing what we expect. Okay, so there we go. So see, now when I ran this, you guys can't see, but I got a notification saying Docker wants to access this folder. Do you want to share it? So maybe this is what was happening, is running it as a sub process didn't interact with my desktop. So that's kind of sad. And then actually I went and did this. And there we go. Now we got a whole bunch of stuff in there. So maybe that's the problem. Is this is more like a Docker for Windows thing, where running it as a sub-process, maybe because Google Test tries to capture things, I don't know, might have set up an environment where this wouldn't have worked. Maybe. Apart from that, this actually didn't fully work. And that's because, that's because I'm still trying to make the target all the way to the binary folder. And we don't need to go that far. So yeah, because I didn't copy like this, there's this trying to call this Python tool that I wrote. I don't actually want it to do that. So okay, before I get to that, let's go back and try to debug this and see if we get a little further now. See, I don't like that the fgets is not working. And my process return is still 1. Or maybe it's failing because make is failing, and so that's returning. Yeah, that actually would make some sense. I'm not seeing the standard output for this. I'd love to see it. Let's see if we can get something. I'm probably just doing this wrong. Or maybe I need to read stood error. Ah, perhaps. So it looks like it would be very similar. Let's give this a whirl. So my pointers seem valid. I've got 2 different pointers here. Ah, now we are getting something from stood error. Let's see what we got. The input device is not a TTY. If you're using Minty, try prefixing the command with winpty. I've seen this before. This has to do with the routing. Let me see. I might need to create my process with the option that says it's a shell. Let's go take a look at subprocess create here. What are these options? Oh, I could even do this. Stood out and stood error are the same file. That's useful. The child process should inherit the environment variables of the parent, enable asynchronous. So this doesn't say anything about a shell. What's outputting this? Is this coming from Docker? It is from Docker. Okay. After I run this, I'm getting the RD input. What should I use here? As suggested by the error message you obtain, you should try to use winpty, which is installed by default with git bash, and thus run. If this works, you may want to set a bash alias to avoid manually prepending winpty all the time. Why am I getting this? This probably occurs when running with IT option using bash terminal on Windows. You can use PowerShell to resolve this. You need to connect the shell to the Docker daemon by setting the env variables from the command docker machine env default. You can also use the Docker quick start terminal, which is connected to the Docker daemon. Did you start Docker quick start terminal? Then I remembered that when I installed Docker on my Windows 10 something called Docker quick start terminal got installed. You need to start that first from that dumb Windows type here to search thing on the taskbar. That launches this. You can run Docker commands there without getting that error or running winpty. Remove -it from the command. If you want to keep it interactive, then keep -i. So I guess I don't need. Is that what that means? I forget now. What the Docker -it or what IT does. That's fun. Here. For interactive processes like a shell, you must use -i-t together in order to allocate a tty for the container process. -i-t is often written -it, and you'll see it in later examples. Specifying -t is forbidden when the client is receiving its standard input from a pipe. So I guess I don't need that, because I don't need it to be interactive, right? But what do they mean? Okay, -i, keep standard in open even if not attached. -t, allocate a pseudo tty. Okay, all right. So if I didn't have this, seems to work fine. Oh, so now we're getting stood out. There you go. So it's actually running it. So let's do all of that. So there's the output. Any error? Looks like we're getting some stood errors. Okay, so there's some errors. I'm gonna do the combination of both because it's kind of weird getting them separately like this. And then we do a join, and look at that, we got 2, which is what we saw when we echoed the error level here. So that's great. That's awesome. This is perfect. Let's do that combination thing that we saw before, so I can get the error and stood out and stood error interleaved together, which is way more useful. So combine stood out stood error. So I guess what that means is I just need stood out alone. Okay. So now I suspect I don't need this and I don't need this. So let's see if that's true. I mean, I guess it's working because I've got errors here. Let me just to make sure, I'm just going to copy this. It's possible that the errors were coming out at the end anyway, so it's not going to be super easy to tell. But let's say I copy this here. And we go back to what we had before. Yeah, we were getting the stood error at the end. So let me, here's what we're going to do. We're going to open up Beyond Compare instance. We're going to copy this in here, and we're going to copy this output here. And we're going to compare. Okay, so there you go. So you can see that the interleaving here. So the left is when they're interleaved. So you see this error here, this error. These are ended up at the bottom here because I was separating the two streams. So yeah, we're going to keep them together so that it's exactly like as if you would have run it at the command line. So that makes more sense to me. I don't know what to say. I mean, it's just for test output, right? What I'm probably going to do is wrap all this up in a little like C++ class so that I don't have to type all this out. This is a C library. I'll make a little C++ wrapper, and that'll make it easier for me to use. That's funny. Put comments in there, take them out, and then it does that. Okay. So now to make this pass, you can see it's all here. See, ultimately this is what I want. No, not this guy here. I want main.lst, which does not exist. Oh, there it is. So this is the file that I want. And then what we're gonna do is we're gonna actually parse this file. So you see it's got all the stabs info in there. And this is exactly what we need to pass to the RST parser so that we can start doing our tests. So we're almost there. Just gonna go work on that make file in the build template. Haven't looked at this file in a while. Don't even remember how this works. Produce final vec file from the .bin. Where am I specifying that I want that? I guess it's up here. This must be this. Maybe it's this. Ah, okay, so it's the all target. So what we want is we want to replace all, I think, with what? Simple.s19. Let's try that. I'm actually going to run it from the command line till it passes. Oh, right. I'm running it out of the build template. All right, let's modify this one. And I'm going to try not to get confused because I have two different files here. Okay, that looks good. So let me try this with clean. Okay, everything's gone. And there we go. So now it works. Error level should be 0. And we have our main.rst here. Okay, now again, not to get confused, this is the one in the temp folder. So that's the one I want. Okay, so now our test should pass. If we run this again. There we go. Process result is now 0. So this totally passed. Sweet. So this means I should now have a file in builder called main.rst. There we go. And after that, we would do the parse RST and all that. So this would be something like RST parser, in fact, debug symbols, RST parser, and I think this takes the symbols. By ref. And we parse it. So expect true here. And then after that, we can start checking stuff. So as a quick test to see if this actually did anything correctly, symbols dot get symbol by name, I guess. What do we expect? We expect to find a symbol named A. I don't even remember anymore. It's been so long. Symbol is a name and an address. That's actually not what I wanted to get. So this adds types. How do I get my types back? I think what I do is I get a function, and then from a function I'm able to iterate over its scopes and all that. So I suppose then what I would do is get back the main function. I don't even remember. This is why we do this stuff. So I think what we want to do is so functions are added as symbols. That's good. I think I had a special thing for main. Okay, so it looks like this. This would get us back a symbol pointer. That has an address and a name. That address, I think, is what I can use to get back get function by address. Shared pointer to a const function. So here's a scope, and a scope has variables. is a vector of variables. Okay, so it should have variables if it should have a valid scope because there are variables. Is there like a pointer expect? I don't know, maybe expect true. Probably should write like I'm gonna need to write some helpers for testing purposes, because obviously I don't need to be able to like look up stuff right now through the debug interface, which is why I don't have an easier way to get to these variables, since the debugger basically just, you know, gets the variables of the current scope and displays them, so it iterates through them. It doesn't say, oh, get me the one by this name. Mind you, I will want to add that functionality eventually to the debugger for like if you write expressions. I'm gonna want to go look it up by name, but yeah, for now I don't have it. So I expect to find basically a variable called a of type int in my variables. In fact, there's only one of them right now, so it's exactly what I should get. Does that work? We also expect the type to be of type integer. I'm not going to be checking the names. I should do here so the type should be a primitive type. And its name should be int. Okay, let's see how this goes. Oh, I guess I should remove that. Unknown file error. Why am I not hitting my breakpoint here? I can't even get to this first line. It's super strange. What is this error I'm getting? Unknown file. Okay, now I'm getting in there. Oh, right. So something goes wrong upon entering the function because I try to instantiate this on the stack, maybe? That's possible. Is that a stack error SEH exception? So structured exception handler. Ah, this is possible. It is possible. Is there something that would be maybe this here? Ah, yes, that's a massive, well, massive. 64K of source locations. Okay, well that'll do it. So what we're going to do here is we'll do it like this. Make unique debug symbols. I'll do the same thing for the RST parser. And this will become like this. I guess I'm getting structured exception handling because this is Google test. Okay, well actually now I'm in here, so that's already a good. But we're already further than before, so that's great. Let's get here. And then we parse. There we go, parsing RST file. We did not fail, so that's good. Excellent. So let's bring this back. So I'm gonna have to change a couple of these dots to Whoops. Okay. Let's see. There we go. For sure, like running these tests is not going to be super fast, as you can see, because having to launch this external process, having to parse, these are all pretty slow operations. I think that's okay. So we got our main symbol, we've gotten back our main function. It has a scope. Now let's see if this worked. We got a variable. Its name is A. It is a primitive type. And its type name is int. Excellent. Perfect. I guess technically what I should do is one of my tests, well, I guess it is this primitive one. I need to not only see that they're added, but that all the values are as I would expect. So like, you know, for example, here for the integer case, we go auto prim type, let's say. So this should be a primitive type. But what we want to do is we want to make sure that the primitive type has the values we expect for int. Right? So like byte size, in this case, should be 1 or 2, depending on compiler flags. I even forget, what is this again? Format? Wow, there you go. Int char float. Is signed, should be true. Is signed, byte size, and format. We'll check that first. Okay, so let's just launch this without the debugger. I just want to see what it feels like. There we go. So passed all those tests. So now obviously here variables of 0 is exactly equal to integer. I don't know, I won't be able to rely on the ordering. I don't think we can. I don't know if I should say. So most likely what I want to do is be able to do like a, from a scope, get a variable by name. You know, so I'll say give me back A, and then it should return the variable that has that name. So I won't actually have to do this check here. I'll just make sure it returns something, and then after that I can do these things. Because basically I want to be able to, like, you know, I'll have to put all the types, char and all that stuff here. In fact, I can even probably find one of the initial tests I wrote manually. Where is it? Here. Like here. Yeah, that's great. So this gets me all the primitive types. I don't actually need all this code from this specific test, but you know, something along these lines. All right, because I couldn't initialize it this way. And I guess I should call this primitive types. So see, now I should have 1, 2, 3, 4, 5, 6, 7, 8, 9 local variables. And int should no longer be the first. I don't remember if they get added in order. I think they must. So like this should be 0, 1, 2, 3, 4. The fourth one technically should be int. Again, like I said, I don't want to rely on that. Yeah. But just to see if this actually works as I remember. FDCUCI 0, 1, 2, 3, 4. Yeah, so it really is in order. So that's good. So this should all pass. Yep. So now we're or not quite. Oh right, it's not called A, it's called I. That's all right. So this is great. This is a really, really good start. Obviously, I have a little bit of refactoring to do to make this useful in general. I need to write some helper functions so that I can write many, many more tests this way. I'll want some little function here to check each type as a primitive type. So just a simple function will do. And yeah, and I think we're in business. Okay, so guys, I'm going to stop it here. Pretty happy with this progress. And I'll resume this work next week. Should be back on Tuesday, same time, same place. So thanks for watching, and I'll see you guys next time.